Let w be cosine of 2 pi over 5 plus I sine of 2 pi over 5 shows that w is the root of the equation z to the power of 5 minus 1 is 0. To show that, we just consider w to the power of 5 minus 1, and we should show that it's 0 as required. So w is this, so it becomes cosine of 2 pi over 5 plus I sine of 2 pi over 5 to the power of 5 minus 1, and to raise some complex number to power, we use the Mars theorem, and it says that it becomes cosine of 2 pi times 5 over 5 plus I sine of 2 pi times 5 over 5. This formula is given in a data booklet, minus 1, and it is equal to cosine of 2 pi plus I sine of 2 pi minus 1. Cosine of 2 pi is 1, sine of 2 pi is 0, minus 1 is 0 as required. Hence, w is the root of the equation z to the power of 5 minus 1 is 0. B. Shows that this is equal to w to the power of 5 minus 1, and deduce that this expression is equal to 0. So you need just open parentheses on the left hand side, simplify, and show that it's finally w to the power of 5 minus 1. It's easy, I will not do that, and deduce that this is 0. So from the previous result, w to the power of 5 minus 1 is 0. Hence, the left-hand side is 0, and we can see that the left-hand side is a product, and product is equal to 0 when it's 0, and it doesn't matter what this expression is, or it may be this equal to 0, and it doesn't matter what this expression is. But, or since w to the power of 5 is 0 and w is not 1, it's not 1 because w is this expression, and definitely it's not 1. W minus 1 is not 0, and since this factor is not 0, to all expressions the left hand side to be equal to 0, this factor must be equal to 0. So then w to the power of 4 plus w cubed plus w squared plus w plus 1 is 0. The next shows that cosine of 2 pi over 5 plus cosine of 4 pi over 5 is negative a half, and notice that it is given hence only, not hence or otherwise. Hence implies we must use the previous result. So let's consider w to the power of 4 plus w cubed plus w squared plus w plus 1 is 0, and w is this, so it becomes cosine of 2 pi over 5 plus I sine of 2 pi over 5 to the power of 4 plus cosine of 2 pi over 5 plus I sine cubed plus the same squared plus cosine plus I sine plus 1 is 0. And again, the Mars theorem, and it becomes cosine of 4 times 2, it's 8 pi over 5 plus I sine of 8 pi over 5 plus cosine of 6 pi over 5 plus I sine of 6 pi over 5 plus cosine of 4 pi over 5 plus I sine of 4 pi over 5 plus cosine of 2 pi over 5 plus I sine of 2 pi over 5 plus 1 is 0. And you can deduce that to get this expression, all other terms must be simplified and they cancel. So and you can see that all terms with I disappear at all, and what we can see here, and we know that for example, if we add or subtract any number of periods, we get the same result for sine or cosine. Also, we know that, for example, sine of pi minus theta is the same as sine theta. Cosine of pi minus theta, it's minus cosine theta. It's from a unit circle. For example, sine of 30 is the same as sine of 150, and cosine of 30 is the same as minus cosine of 150. So 2 pi here, it becomes 10 pi over 5. So it's sine of 8 pi over 5 is the same as sine of 10 pi over 5, it's 2 pi, it's period, minus pi, 2 pi over 5 to get 8 pi over 5. So we just it's actually the same. 8 it is given as 10 pi minus 2 pi over 5. It's actually the same, but if you add or subtract any number of periods, you get the same result. I mean that, for example, sine 30 is the same as sine 30 plus or minus any number of periods, 360 in degrees, k or 2 pi k. So it just sine of negative 2 pi over 5. But sine is odd function, so it's minus sine of 2 pi over 5. Odd function, it means function of negative x is minus f of x. Even function of negative x is function of x. Cosine it's even, all other, I mean sine tangent are odd. So we get that this is minus this, so these terms cancel. Then you can guess that we get the same for other two terms with I. So sine of 6 pi over 5 is the same as sine 10 pi over 5 minus 4 pi over 5, and similarly it's sine of negative 4 pi over 5, so it's minus sine 4 pi of 4 pi over 5, so these also cancel. And now let's consider cosines. You can see that there must be only 2 pi and 4 pi over 5, and we can see 4 pi, 2 pi, so we can do the same with cosine. So cosine of 8 pi over 5, it's similarly cosine of 10 pi over 5, which is 2 pi minus 2 pi over 5, so it's cosine of negative 2 pi over 5, but cosine is even function, so it's the same as cosine of 2 pi over 5. So it becomes this. It's the same as cosine of 2 pi over 5. Oh, there is cosine of 6 pi, so let's do this. So cosine of 6 pi over 5, it's cosine of 10 pi over 5 minus 4 pi over 5. It's cosine of negative 4 pi over 5, so it's just cosine of 4 pi over 5. Hence, it becomes cosine of 2 pi over 5, it's this one, plus this, it's cosine of 4 pi over 5, plus cosine of 4 pi over 5 plus cosine of 2 pi over 5, so we can just multiply by 2, plus 1 is 0. And hence it's clear that cosine of 2 pi over 5 plus cosine of 4 pi over 5 is negative a half as required. And that's all for this question.